Before we take a look at if structures, let's dive into this program and see what it would do if we just ran it normally. So first command, start motor, right motor 127, starting that motor full speed, let's call that forward, waiting 2 seconds, then stopping that motor. Then it would start the left motor, let's call that backwards, for at half speed and for 3 seconds, and then it would end, which would effectively stop that left motor. But let's say that we wanted to essentially make this thing go left or right, whatever it is, based on a sensor input like a line follower. So I'm going to put in a if statement, and I'm going to use one of these big ones, the if body else. Well, let's just do if. Let's just do if body. If fixed formatting, and so if I took all of this stuff, Control X, and put it in here, and let's say sensor value, line follower, let's say less than 1500. So if the sensor value of the line follower is less than 1500, it is going to do this stuff. Otherwise, it's going to do nothing. So I think we can see the problem here. I highlighted it in the last video. So we start the program, and let's say the line follower value is reading at 1501. Well, that evaluates this statement, or this check right here, and it checks and it sees, oh no, this is not true. It's greater than 1500, so it's going to skip everything that's attached to that, and that's those brackets. That's why fixed formatting really helps us. And it skips all the way through those, and then boom, it ends the program. So that's where this if condition body else body helps. So I'm just going to get rid of that fixed formatting for myself here. And let's say that we took out this and toss that down there. Let's even put a stop in here. Left. So what we have here is right now, the first time it runs through the program, it checks to see if the line follower is less than 1500. Let's say it's at 1501. Well, this is not true, so it skips all of that bracket that's attached to that if statement. And because it's not true, it's automatically going to do what's inside of this else. So I think you can see that this is actually going to be a problem as well, because this is only going to execute once, and that's one of the key features of an if statement. If an if statement is true, it executes one time. If a while statement is true, it executes over and over and over and over and over again, as long as that condition continues to evaluate to be true. So while this evaluates to be true, it may continue to evaluate to be true, but it's only going to do it one time. So what we end up doing is oftentimes we use the while loop and the if statement, or the if structure, in conjunction with each other, and so we end up doing something like this. 1 equals 1. That essentially says while true, and it's always going to remain true. And we put those brackets around everything, and now it gets stuck inside this while loop. So from here to here, it executes that command over and over and over again. And really all that command is doing is just reading this if statement as fast as it can. And when the sensor value of the line follower is less than 1500, it starts the right motor, waits 2 seconds, and then stops it. When it's not true, it starts the left motor, waits 3 seconds, and stops it. So it's actually not checking this value that fast. At best, it's checking every 2 seconds, because that wait command right there stops it over and over and over again. So a more responsive way to get this to work over and over and over again. Well, I'll let you think about that. I'll let you think about that for right now. that's, I think, a lesson for another day. Probably want to get back on Wednesday. I think you've got a basis for if statements, a basis for while loops, and how do you combine those in order to make your program do some things. I will show you how to really do some more advanced stuff when we get back on Wednesday.